first video for this unit on differential equations. Again, you can read some of the text that I go through in this lesson because I'm going to just be focusing on kind of the applications and doing the problems here. But the key thing that you need to take away about differential equations is that it is an equation that involves some unknown function, y, equal to f of x, and then it will also include one or more of its derivatives. Okay, so that's kind of the key thing I want you to take away here is how to determine if it is a differential equation or not. You're looking, does it include the function y as well as one or more of its derivatives, okay? So let's just look at verifying that this function y is a solution to this differential equation y prime plus 3y equals 6x plus 11. All right, so the first thing that what I do is when I look at the differential equation on the right is I notice it has y prime in it. So I'm going to take my y and I'm going to find y prime. All right, so I'm going to do the derivative of e to the negative 3x plus 2x plus 3. All right. Now, if you guys remember from your days in the first semester, when you take a derivative of the natural exponential function, all right, you're just going to copy it down. So e to the negative 3x power. But then you also need to do the derivative of the exponent. And the derivative of negative 3x is negative 3. The derivative of 2x is 2, and the derivative of 3 would just be 0. So this is my y prime. So now I'm going to plug in everything that I know now, since I know the derivative of y, into my differential equation to see if this is actually a solution. We know it is, to verify that it's a solution to this differential equation. So I have y prime. So I have negative 3 e to negative 3x plus 2x, and then plus 3 times my original y function, e to the negative 3x plus 2x plus 3. All right, now you could write it, if you wanted to, equals 6x plus 11. All right, that's what I need to get when I'm all said and done. All right, but I already know that's the right side. Okay, so I'm going to copy this down. And then I'm going to distribute. So 3 times e to the negative 3x is positive 3e to the negative 3x power plus 6x plus 9. All right, you'll notice that these natural exponential functions, or pieces I should say, are going to cross out. We're going to have a negative 3e to the negative 3x power and a positive 3e to the negative 3x power, so that's going to make 0. So 6x plus 2x, hold on, I did something wrong here. 1 second, what did I do wrong? 1 second, let me find it. Okay, sorry about that. I made a mistake earlier when I found the derivative. That's on me. The derivative of 2x is just 2. So this should have been plus 2. That's plus 2x. That should still be plus 2x. Okay, there we go. That makes more sense. That's on me. That's my fault. So now when I combine like terms, I actually am going to just copy down the 6x. It doesn't have a like term, but my 2 plus my 9 is going to make 11. All right, so that equals the right-hand side. All right, I apologize for the mistake. My bad, that's on me. Okay, so that's what it looks like to verify this solution to a differential equation, all right? Now, another way that we can look at characteristics of a differential equation is saying the order of a differential equation. And the way to find the order of it is just the highest order of any derivative of that unknown function that appears in the equation. So like in this first one, right, this first differential equation here, the only derivative that occurred was the first derivative, y prime. So the order for that differential equation would be an order of 1. Okay, so let's look at the same idea for this one. Just like the one I just mentioned, in part A, you've only got one derivative, it's y prime. So the order is going to be 1. In part B, you've got actually 3 instances of derivatives. You've got y triple prime, y double prime, y single prime. So the highest one is going to be the third order, y triple prime. And then I know it looks weird, you've never seen that before, but in that parentheses, that means y quadruple prime or the fourth derivative. All right, so we have 2 instances of derivatives, but that is going to be the highest order derivative, the fourth derivative. All right, so that's how you define it in terms of the order. Okay, now, one thing that we're going to do is we're going to find particular solutions to this differential equation. And if you look at it, this is as basic as you can kind of get it, because what we have is we have y prime equals 2x, all right? And I know that if I had y equals, all right, it would be y equals x squared plus c, right? And where c is any constant, because if you take the derivative of a constant, it gives you 0. So if I take the derivative of x squared, I get 2x. So this is my general solution to this differential equation, y prime equals 2x. But to find a particular solution, which is what this example is asking us to do, we're going to plug in this ordered pair 2 and 7 to figure out what our constant is going to be. So I'm going to replace y with 7 and x with 2, and then solve for c. All right, so c is going to be 3. All right, so my particular solution to this differential equation of y prime equals 2x is going to be y equals x squared plus 3. All right, so that's one way that we could be asked to find a particular solution to a differential equation. Okay, here's another verify one. All right, so we're going to verify that this function for y is a solution to this differential equation. All right here, right? This is my differential equation. But then a second step is going to occur where we also need to make sure that it satisfies this initial value. Okay, and this is what constitutes an initial value problem. So I'm going to treat this first off like we did the very first one and find the derivative of y. All right, so I'm going to do d dt of 2e to the negative 2t power plus e to the power of t. All right, just like before, when you have the derivative of that natural exponential function, you're just going to copy it down. All right, the derivative of negative 2t is negative 2, but there was already 2 in front. That's going to multiply together to give me negative 4. And then this is just going to be e to the power of t. Okay, so I'm going to plug this into my differential equation. So negative 4e to the negative 2t plus e to the power of t plus 2 times my original y function, 2e to the negative 2t power plus e to the power of t. Okay? Now again, all of that is going to just be equal, hopefully, 3 times e to the power of t. That's the hope. So copy this down. Okay? Distribute. You get 4e negative 2t power plus 2e to the power of t. Just like before, these are going to cross out. Right? These are opposites. Positive 4e to the negative 2t power and negative 4e to the negative 2t power. That's going to make 0. All right, and if I add e to the power of t plus 2e to the power of t, I get 3e to the power of t. All right, so that's the first step in verifying that this function is a solution to the differential equation. So that's like the first thing that I have to check. Now, the next thing that I'm going to check is I'm going to plug in 0 for my t, and I hope to get 3 for my y value when I plug this into the initial, or I should say, the function for y. All right, so you'll notice the second thing that I check in verifying this initial solution problem is actually going to not deal with the derivative at all, or even the differential equation. It's just the original y function. All right, so I'm going to copy down the y function, which is y equals 2e to the negative 2t power plus e to the power of t. And I'm going to replace t with 0, and hopefully that gives me y is 3. So y is going to be 3, hopefully. And I'm going to write negative 2 times 0 plus e to the 0 power. All right? Anything to the 0 power is going to be 1. So 2 times 1 is 2. Anything to the 0 power is 1. And 2 plus 1 is equal to 3. So that's the second step in verifying that this function is a solution to the initial value problem, is making sure that your initial value makes your function for y a true statement. And it does. Okay? All right. Let's do one more. Now, this is another variation on this initial value problem. You'll notice that they give us the differential equation, right, as well as they give us the initial value. But what we have to do is we are not given y, right? We don't know, put a question mark there. We don't know this function y, okay? So what I'm going to do is I'm going to take the integral, so the integral of both sides, the integral of y prime, and then the integral of 3e to the x plus x squared minus 4. All right, so the integral of y prime is just y, right? That probably makes sense. But I should put plus c, I'll put like a little subscript of 1 here to show you that, you could have y plus 6, y minus 9. It wouldn't matter what that constant was. You would still get the derivative of y as y prime because that would be 0. So let's do this one here. I'm going to write e to the power of x, and the derivative of x is just 1, so I'm going to bring down that 3 with it. All right, derivative of x squared is 1/3 x cubed, and derivative of the constant is at minus 4x. All right, again, plus c, and I'll just label this as my second constant. Now I'm going to move this constant over and write y equals 3e to the power of x plus 1/3 x cubed minus 4x plus c with my subscript 2 and then minus c subscript 1. But you'll notice that if I just subtract these constants, which I don't know what they are, I can go ahead and just take those two constants and write it as one constant. So I'm going to copy this down one more time. But where I see those two constants subtracted, I'm just going to write it as one constant. So just plus c. All right, so this right here is what we call a general solution to this differential equation. All right, but in order to solve this initial value problem, I need to plug in my x is going to be 0 and my y is 5, so I can solve for c to find this particular solution to this initial value problem. So I'm going to copy it down again. Y equals 3e to the power of x plus 1/3 x cubed minus 4x plus c. All right, and now I'm going to plug in 0 for x, and y is 5. Okay, anything to the 0 power is going to be 1. That's going to be 1 times 3, which is 3. But then all of that is all 0, right? 0 cubed is 0. 0 times 1/3 is 0. 0 minus 0 is 0, so that's just going to be plus c. So c is going to be equal to 2. So my solution here is going to be y equals 3e to the power of x plus 1/3 x cubed minus 4x plus 2. So this right here is our solution, particular solution to this initial value problem. All right, so give it a go in terms of the homework. Hopefully you can practice doing some of these problems and working with basic differential equations.